Acid strength. Okay, so we talk about strong acids. And what a strong acid is one that ionizes completely or dissociates completely when it's dissolved in water. So you've got your HA, whatever A is, and you add it to water, and all of it goes and forms the products. You don't have any left that doesn't. Acid strength has nothing to do with how corrosive or dangerous or concentrated the acid is. We're talking about how much does it dissociate, how much does it ionize. Here the word strong is used in the same way as when we talked about strong electrolytes. Strong electrolytes dissociate completely and they conduct electricity well. Strong acids are also strong electrolytes because they form a lot of ions. In a weak acid, very few of the acid molecules ionize and come apart. Most of them remain intact. And so it's only going to conduct electricity weakly. It's a weak electrolyte. It's a weak acid. That doesn't mean that it's not, corrosive or dangerous or anything. Like, if you had a weak, I don't know, my analogy thinker is getting tired.
How are those two equations different?
How are they different? That's a good question. The arrow's pointing in the other direction. Tricky. So in the weak acid, it'll be mostly these guys. So if you put weak acid in water, very little reaction will occur. Whereas if you put a strong acid in water, it will react and form hydronium ions and the conjugate base of that acid. And there will be very little of this left. There's a slide here that's going to help us to understand. So here is an example on the top of a strong acid. Initially you put in this amount of the acid, and then after you mix it up, what you have left is basically no acid molecules. All you have are the hydrogen ions, which are riding on the water molecules. They're not out there by themselves. They're being held, but we don't care who's holding them. They're just that they're being held. So we just call them hydrogen ions. Hydrogen ions and the anion. And if we look at the picture here, there are no intact molecules in this beaker. All of the molecules came apart. For a weak acid, adding the same amount of acid, you're only going to get a little bit of hydrogen ion and a little bit of anion here. Most of it is going to still be the intact molecules. And so when we look at the picture in the beaker, we see, well, there's one hydrogen ion and there's the anion, but most of them are still stuck together. Okay, does that make sense? Strong acid comes apart completely into ions. It conducts electricity strongly because of all those ions. A weak acid dissociates only a little bit. Question?
If you put that acid in the solution,
Mm-hmm.
I know we wouldn't see like little dots.
Right.
But would it look like anything?
You wouldn't notice any difference. Most acids in water are colorless, and so if you took if you had a solution of a strong acid and a weak acid, they'd both look like water. They're going to look exactly the same. Yep. There is a short list of strong acids. Your book just names 4 of them. There's actually 3 others, but these are the only ones we're going to worry about. So sulfuric acid, hydrochloric acid, nitric acid, and perchloric acid. And those are all ones that we're somewhat familiar with. All of those are strong acids, and we're just going to assume that any other acid we talk about is a weak acid. And I'll give you this list of strong acids on an exam where there are any questions about it. So if you need to know whether it's strong or weak, you'll look at the list. If it's not on the strong list, it's weak. Okay?